can't go running if you're injured. Yeah, but it wasn't broken. Yeah. That was the Sunday after, I thought. Okay, then it was the morning of that run. Can you share this? Oh, you've got the slides. You want me to kick it off? I think feel free to take the mic. All right, good morning, everyone. This is our Thursday session 1. We are going to be discussing the notion of doing network attestations for secure routing. This is a non-working group forming BOF. So just wanted to make that clear. The session is being recorded. I've got Peter and Hank, who's just left, not a good sign, as our note takers. So with that, let's go ahead and get started because we have a full agenda. Next slide, please. So it is now Thursday. Who are new attendees to the IETF? Great. Oh, okay. So hopefully you've attended other sessions, so you're familiar with our processes and procedures. So just please note the well. Next slide, please. So meeting tips, also again, make sure that those that are here scan the QR code so that we can tell and gauge the level of participation so that presuming we have another BOF, we can schedule the right size room. And I'm just going to let you guys go and read this since it's Thursday. Most of you should know the drill for the connections. Next slide, please. Okay. What's that? Okay. So again, thanks again to the note takers. We do have a data tracker for this as well as a mail list. So again, hopefully you're all participating in the mail list. There's they've started a proposed charter, but I think in this session we want to make sure that everybody understands the problem, the intent, and we can get into the discussion of relevance into the IETF. So next slide, please. Okay, so resources, we'll just went over that. So agenda bashing, I'm going to do a quick call, believing that everybody has looked at this, and you can look at it right now. We do have a very full agenda. I want to make sure that we allow enough time at the end for discussion so that we know what we need to do moving forward as the next steps. So with that said, I'm going to do a quick call to see if there are any comments or questions. Go ahead, Michael.
Yeah, Mike Perrock here. Just a quick question. Did I hear correctly? It's a non-working group forming BOF,
Correct.
yet there's a charter kind of in development, and this looks like a lot of materials that I would typically see in a working group forming BOF. So I was just curious the stance on that, timing, approach to process here.
Right. So part of this, Mike, is even on the first BOF, it goes to the question of, are people really understanding? So I believe it might have been Peter proposed. So there's been discussion. So let me get to why we're here, and maybe that will explain it, right? Because I think Roman, as our IETF chair, has said we get 2 tries to make sure that the community understands before we make that decision of whether we create a working group or not. Was there any other? No. Okay. So let's get to why are we here. So Mike, this is what I started to say. Discussions have started. There is a mail list already there. There was a side meeting in Brisbane, and I think that was about the time that I was going to say the wiki. Sorry, it's Thursday. It's morning. My brain is not quite functioning, apparently. So basically, there are some documents there that are there to describe the understanding of the problem statement and intent. So the 2 paragraphs that you're seeing here, I'm not going to read it. You guys are adults. You can read it for yourselves. It's on both the GitHub and on the drafts, but it gives you the examples, the description for the interest and intent that they want to pursue here in the IETF. Okay, go ahead.
If I can add a comment concerning the charter, is just because on the mailing list, the people just worked a lot in the last 3 months between the 2 meetings. So they just started to go ahead a little bit and start to think what the charter looks like, but we are not there yet. So it's just for the future.
Yeah, so Mike, historically, charters get started well before we even have a formal BOF like this, right? And so it's just meant to have some words in there so that people have something to better understand and then comment. So I've done a couple of working groups where that text was 100% completely rewritten, just FYI, right? Okay, so things, are you getting in the queue, Torles?
Yeah, sorry, I hadn't put out the notebook. Did you want to have comments on that kind of pre-charter summary text here?
No.
Okay.
We'll have that in the discussions. Okay, so during the side meetings and even within the RATS working group, there was discussion. There's a draft in the RATS working group on how we could achieve, I think that draft is called a trustee secure path. And so the question that we're posing here, and it's not so much a question, but because this is a non-forming session, it's more to raise the awareness that there are other working groups, both in the security and then the routing area, that have relevance or interdependence, if you will. So RATS, obviously, we're talking about attestations. That working group focuses on achieving remote attestations, and so it would be those claims, evidence and verification that would help towards the secure routing path. Luigi, you want to talk about the other working groups? Because that's more.
Yes. So when the request for the BOF was submitted, the ISG asked clarification on the relation with subnet. Okay. So the group discussed with the chairs of subnet, and the conclusion was that the technologies will be orthogonal in a certain way, because somewhere subnet you deploy it at the boundaries of your domain, whereas whatever technology comes out from this effort will be deployed all along the path that you want to attest and secure, and you want to have the proof of transit. And there is a text we agree upon, which is also here in the slides. There is a second relation is the panel G. We sent an email to the chairs. We didn't get a chance to talk with them, but I'm sure we will work out as well a text that clarifies the differences. Okay.
Okay. So are you getting on the queue?
Yes.
Okay, please make sure you use the queue so we know.
Yeah, sorry.
And state your name and affiliation
Yes,
too, especially
sure.
for.
Affiliation retired, but for a quarter of a century I was an operator.
Excellent.
I wonder, you have secure routing in the title, and the one long-term secure routing activity that has been there is not being mentioned. That doesn't have a protocol. Well, okay, that's represented in CyberOps as a working group, but I wonder how secure routing can actually ignore completely what has been done for more than a quarter of century now.
Yeah, there is some so the term that has been used can be misleading. On this we can agree, and this was comments we already received. The point is, this effort is not about securing an existing routing protocol. It's not about CIDR, for example. Okay, it's more about the routing is done. I can choose a path that has the level of trust that I want. Okay, and how can I ensure that actually my packets go through that? So it's not about securing BGP or any IGP protocol. So we can agree that the terminology can be refined.
How do you do the stuff on top if you have not secured the underlying mechanism?
You're gonna discover in the next presentations.
So sorry, I really need to make the comment. So the problem is using the word trust without, explaining trust to do what, to be what, right? So that's the missing thing, right? Is it you're just trusting that the routing protocol is working, that the forwarding is working, right? So
Okay,
that's
so we are facilitating the session. I think it behooves us to have the presenters present the use cases and the problem statement before we can have the discussion. Okay? So with that, let's just jump into it then. And then Mei Ling? And we're
Hello.
sharing your deck.
Okay. Okay. Hi, guys. Good morning, good evening, or good afternoon. I'm Mei Chen from China Mobile. As one of the NASR proponents, I will spend almost 10 minutes sharing our considerations on secure routing from the role of network operator. Next slide, please. As we all know, network providers are very sensitive to routing attacks. Traditional routing attack always try to disturb routing information propagation, then result in traffic misdirection. There has an assumption behind. All devices in a limited domain are trusted but untrusted in internet. Obviously, there are no additional approach is needed in the limited domain. On the contrary, for devices in internet is totally insecure, we think. So for the internet style, it is a best effort model, although there are some other methods like BitBSec. It can only ensure announcement security. So they have no guarantee of each device's forwarding decision and even cumulative forwarding result. Now, new requirements appeared for secure routing. Some of our clients would like routing data only on top of trusted or secure devices. At present, there is already some foundation technology. Device trustworthiness can be decided by remote attestation procedures. As the goal is to actually dependable forwarding hub by hub. So how to do it? There is very simple way, I think. Perceive this device and the past trustworthiness and make routing decisions regardless of domains where they are in, internet or limited domain. Next slide, please. So like all all programs, starting from requirements and completing in multiple stages. Security routing follows the same logic. We have divided it into 3 stages. The first stage is node trustworthiness. The nodes such as individual device or security function. At this stage, we need to confirm the node is dependable and the node have security capabilities. This is a form of static security. At stage 2, I summarize it as path computation and orchestration. This is the responsibility of network operators. Ensure paths dependable and have capabilities to anti-cyber attacks through various means. Is in the scope of dynamic security. At stage 3, this is also the most important step, I think. Is the customer's most important care about is data frame forwarding, auditing, or visibility. In other words, we need to validate that the actual taken path consistent with the orchestrated path, and the security properties consistent with the user's request. Next slide, please. So why routing paths needs to be more secure? Because new thing has emerged. Let's see the figure. User A with China Mobile Cloud with CMNet, and user B use AI training model with CMNet. That's to see sensitive use data stored in the cloud. AI large models stored in external server. So limited by data security, privacy protection, and laws and regulations, all the data cannot be leaked and cannot go abroad. In this use case, they require internet service providers network can generate a trustworthy, secure, and controllable forwarding pace, which can prevent data leakage, and also pass attestation procedures to prove that path is indeed trustworthy. Next slide, please. In addition, we also encountered 2 other use cases. This comes from the current network requirements when we collected during our security research. We have some traffic that needs to go through a battle of service in a fixed order. When designing the solution, we found that RAS and telemetry is available for node trustworthiness. The protocol SRv6 SRH is adapted to path computation and orchestration, but how to prove that traffic really went through this service? Existing technology cannot support it. Let's see the use case below. We also have some clients with high security requirements. It is not a completely new requirement. In the past, we used list lines to solve it. However, the cost of list line is really very high, and the scope of list line is limited by geography, location. So we are trying to select a trusted path with all trusted nodes. This is an alternative solution and can support the expansion of list line service. So to summarize, these 2 use cases needs orchestrate a path in order and prove the traffic went through this service, and also compute a forwarding path with high security requirements. Next slide. Oh, thanks. Any comments?
1 minute. Okay, there's 1 minute for any quick questions. Okay, if not, we should move on because I think we need to save
Okay.
more time for the discussion. Thanks, Mei Ling. Diego?
Thanks.
So it's I'll try to be fast. Modern use cases. The idea is to talk about well, existing technologies and how we plan to integrate it, and try to, among other things, address what Randy was asking about the control and the data plane, and show that how we intend to apply things on the control plane to establish the path and on the data plane to verify it. Can you move on? So basically, and we're talking about path validation, this is something that we can talk about many different names. I prefer to talk about path validation in general, because with this, what we propose here is not only about the routing, it's about evaluating and validating, independently validating any property that you can be provided by the path, and make decisions and verify them. So the idea is to assessing specific properties, whatever, and that's they are in general related to a security posture, and the main of use cases are related to that. But we are talking about geolocation, that well, the path doesn't leave a particular borders, versioning, features, whatever. And the idea is to go into two stages. One is you attest the path components. This when you establish, or you're going to establish the path, and this is the idea is to use or to base the building of these of the path on RATs, and how you attest the path behavior. One is established, and then you have to do it at the data plane, and you make it during the use of the path. And for that, what we have been experimenting with is the idea of using proof of transit. Can you move on, Luigi? So for the construction, the idea, what we have right now is this proposal that was discussed or has been submitted to RATS on the trustworthy path routing. The idea is that it relies on the mutual attestation of the different nodes in the path through their links, and what you get is the verifier, and associated with the network controller gets the list of which are the attested nodes and interfaces using, again, RATS technology, so it can be applicable in an IP subnet that is controlled by a particular controller. On the other hand, things that you are not, you are able to do this at the very beginning, at the initial path, and this can be done, let me say, by a controller, by a PC, by whatever. And then well, but the problem is that whatever the change afterwards cannot be detected, and everything is in the hands, so to say, of the network provider. There is no protection sites, and well, multi-domain issues are tricky, and we will talk about this later on. Can you move on? During the path behavior, the idea is that once you have established this, and well, you have asked for that, and the network provider has told you that this is there, the customer, the user of the path, can, independently or with the collaboration of the provider, to verify path behavior. This is something, again, is something that was proposed some time ago within the SFC group. It's something that was called proof of transit, and there is something that in one of the RFCs that was related to OIM is part of well, that you have there the RFC. The idea is that well, proof of transit is based on, if you are interested in the details, it's based on Shamir sharing secrets, and this is computed, is a shared secret that is computed node by node, and then is verifiable. And there is we made a proposal for verifying as well order, not only the traversal of the path, using link masks. The the idea here is again is that since you can do it even per packet, it has a cost, but you can do it even per packet, or if you use a dedicated IOAM packets to verify this from time to time. This is verifiable by anyone that is able to inject traffic in the segment that is being verified. So a third party can make a further verification. The customer itself, it's or themselves, and the whoever is can access to that can be that the path properties are being verified because you are following that. Can you move on, Luigi? What we are proposing is precisely mix both of them, so you can link the process of establishing the path by means of this TPA and verifying that proof of transit is there, verifying the identity of those elements that are going to take part in the proof of traffic, in the proof of transit, sorry, and that to generate and verify all the traffic as it happens in the data plane. Still, though, a couple of things that we still is about the multi-domain issues. It's something that is a challenge. I mean, with these pieces, this is something that can happen inside the domain. And again, we have been making experiments with it. Can you move on? And well, the idea is that well, there are several issues that we believe are important. One is about the order. When you're trying to make proof of transit, it's not the same that you have the firewall and then the IDS, or before the IDS and then the firewall. Order is important, and the idea is to work in that direction. And these things in the draft I mentioned, we have these masks. What we think is that we could derive the masks from the statements that are exchanged during the attestation phase. And second is about whatever has to do with interdomain. It is important as well that we can go beyond a single domain, and the idea is how we exchange the material that is relevant for this. In the case of attestation, we're talking about the golden values that are going to be used for examining a certain path. In the case of proof of transit, is how we coordinate the sharing secrets mechanisms. And I think, and we intend to make these issues part of the work in this matter. And that's all, as far as I can tell. Yeah, I know. Now that Roy was looking at me.
Go ahead, Roy.
Roy Williams, Microsoft. I had a quick question, Diego. This seems to assume that you have a static network. Are you going to cover adding new nodes to the system and how that will stabilize into the, or is that out of scope?
That the idea is that whenever you add, if you have a network that is controlled by a controller, a PCE, whatever, you can add those. The controller would know about that. So yes, if you mean for a particular path, once it has been validated.
Well, my concern here is you add a whole bunch of new nodes and all of a sudden your path validation lights up like a Christmas tree and the whole system comes down.
The point is that, I mean, let me say, you are validating here what you have, what you're offering.
That's a static network. Yeah, I understand. But I'm wondering whether adding new nodes is going to be covered in this discussion or not.
I don't see why not. I don't see why not. And I would be really interested in discussing about the details of that.
亮夏华为Diego, can you go back to the POT?
Just FYI, just close the queue after.
Yeah, last one. Okay, this one.
Yeah.
I want to know that your last sentence, no protection against additional nodes in the past, many meter, right? And I don't know the PONT, what does it mean? But
proof,
do you mean
proof of non-transit?
Okay. But do you mean that the current POT cannot protect against this, or you mean you can solve this?
Yeah. No. I mean, it's something you are never protected against is a passive tapping is something that you cannot simply do. If I have physical access to a wire, I can copy traffic. That's something that is, but what you can remain assured that is that not additional processing in the middle. Not
this is I also agree, this is very difficult to
that's
the protocol level is very difficult thing.
In summary, that goes against the laws of physics, and so
But maybe we can. I hope that if we can find a way to solve this, that's very good. But let's see. Okay.
I would love to hear about that.
Okay.
Certainly.
Thank you.
Rüdiger Volk again. Diego, you mentioned that the trusted elements may be controlled by a third instance that's not in the path.
The trusted elements control, right? They are supposed to be part of a network that is controlled via SDN. I mean, we're talking about netconf, we are talking about OpenFlow, we're talking about a control protocol, PCE, whatever.
Yeah, kind of. I can see that I can quite securely fix properties of the static element. Making secure assertions about the configuration, which is usually the part that introduces bugs in operational networks, looks much more difficult. And kind of, yes, if there is another instance out there that is not certified and introducing changes to the elements that are secured.
Two points about that. Let me insist about the secure. If you notice, I have not mentioned the word secure. I'm talking about validation. That's first thing. Second, whether you interpret it as a security property of trustworthiness or whatever is up to you. That's, say, in the eye of the beholder. Second, and the important thing is that, well, two things. First, you can attest as well the controller using RATs, and you can have an assurance that things are as they should. And second, precisely the idea of the verification during path usage is to provide the opportunity of detecting misconfiguration, at least a misconfiguration in what is referred to the forwarding behavior.
We need to move on. All right.
May I start?
Yes.
Yes, I'm Izuka from National AIC Japan. So the next slide. So my talk is mainly about the inter-domain secure routing. So in usual traditional setting, of course, everything is physical, and there is no tunneling network. And also, many proposals assume that there is some kind of uniformly controlled local networks. But in this setting, tracing traffic is very easy because everything is physical and locatable. Next slide, please. But in reality, especially in the inter-domain setting, we have overlays in so many layers, not limited to VPNs, but local network are managed using several overlay technologies. And there are, so even if we track traffic is going in this path, passing switches and routers, everything was in fact virtual. So, and also we have a very complex configuration for infrastructure as a code setting. So assuring is, as he said, very difficult in the real setting. Next, please. So this is one example setting for consideration. So we have the traffic originator and destination in the right side, but it is connected by passing so many operators, and middle pass is VPN connection like this. So in this setting, we should find how we can assure that forwarding is secure actually. So next, please. So and I submitted the individual draft about the problem statement about the verification, but we have to address many things like multiple stakeholders. And what is the expected the correct state is not a simple solution. And also, if we do this kind of verification in the shared infrastructure, we should care that the attestation service will not leak some information about other customers, and also virtualization is making things very difficult. Next, please. So This is my kind of a proposal, a straw man for how we do by defining some kind of services for the pass characteristic verification. So we put some pass characteristic service for each operator. And next, please. And the customer can query how he or she wants the traffic to be served. Like if their ultimate goal is going to server B, but it should first within the network operator A. He trusts in some sense this network, but it should be logged like using the NASR this working groups technology. And VPN path is encrypted, but still he wants this communication like within the European Union or something like that for the legal restriction. And network operator B is in some sense not trusted, so they don't have a requirement or something like that. Okay, next please. So if this kind of requirement is shown, the network operator A can at least verify the property of the internal network using several kinds of technology like checking router configuration or monitoring by NASR or other monitoring dashboard or something like that. But they cannot verify the other properties of the other network. So next, please. So they must cascade the queries to the next hop operator. So like PCSA can ask PCSB that the traffic within that network is securely monitored or something like that. Next, please. And also important point is if a VPN is required, but in some cases this second tunneling network must also be verified. In that case, they can ask PCA for the services in the underlying network or something like that. So can you show this is slide number? Then next, please. Then he can, the PCA service A can gather the responses and go back to the originating as a attestation response or something like that. We need some kind of this kind of services for ensuring the global pass attestation. Next, please. Okay, next. And I will skip some slides. So can you slide for 2 slides more? So yes, and the target, of course, we can do on the layer 3 and layer 2, but important thing is so many kinds of the overlay configuration must be checked in some way. And also, in actually securing the traffic, we must address some kind of the properties outside of the network. This network layer, this is still under consideration for how to do that. Next, please. So this is a summary of my proposal. That yes, next, please. So to realize that we should study on many aspects of the existing network. This is ongoing or future work for this, but we need at least first to design the query language for this kind of services. And how to gather information is the next step, especially for the software managed networks and using various vendors implementation. We must have some kind of adapters or something like that. And also, because query is some kind of a logical assertion, so we also need some kind of the verification engines for doing that. So we can, but in this way, I believe we can work on the solution for this kind of problem. So please make comments are welcome, and thank you very much for this opportunity. Thank you very much.
Okay, we have time for one question. Nicola, I'm going to close the queue.
Hi, Yutaka.
Yes.
Thank you for the presentation, Nicola from Scion Association. So on this kind of topics of interdomain, I think we discussed this before. There is quite a lot of prior art on Scion, in the sense that, we have a path lookup process, there is also a trust model and so on. So, we have basically a specification right now in review under the ICE, and I think this part could be interesting, maybe complementary to NASR. I think it really depends where this thing is going. But I think a lot of the problems that you raise in your presentation is something that we have been thinking about it in that sense. Just wanted to add this as a comment.
Thank you very much. So Scion is I really looking on the Scion, and it is a very promising approach for providing this kind of information. So our focus is how to gather that. Yeah. Thank you very much.
Michael Richardson. On this topic, do you have notions as to what kind of base protocols or things will make PCS? And that's really also a question for Nicola. Is there's something clear than Scion that would offer that interoperator query process?
Okay, my idea is very high level, let's do something like high level approach, bridging information from the network layer to more like on the HTTP or some kind of very high layer protocol using also something like
so that's as far as I had gotten to. So I was hoping you had more. But Nicola, did Scion have that protocol?
So yes, we do have a path lookup process. I think that the lookups between endpoints and the control plane are based on some RPCs, but then there is kind of a recursive process where you go to your own AS, and then if you need to go somewhere else, then your AS can cache or get segments to Scion control plane.
Okay.
So yeah.
Thank you very much.
It's a bit long, but
I will talk later.
Yeah. All right.
Thank you.
Thank you. Next, we have Trusted Connections Services, Yufu.
Hello. Sorry, there is something wrong with my camera, so I can't turn on my camera. Okay.
That's okay, as long as we can hear you and you can see the slides.
Okay. Hello everyone. I'm Yufu from China Unicom. I want to share some use cases proposed by from the operator's view to propose the trusted connection service for our enterprise customers with high security requirements. Next slide, please. So I want to share 3 use cases. One use case is, I think, is the interoperators. So this is, I think, the trusted BGP connection service for enterprise customers. So China Unicom provides the international prevailed connection service to international customers. So we think that is the international physical maybe private line. The cost of this private connection service is very expensive. So with the NASR, we can provide the trusted IP connection service to these customers. They could choose the trusted node for the path forwarding, which will reduce the cost. So we have the customers such as the bank, financial customers, and government customers and hospital customers for this requirement. Next slide, please. The next 2 use case we think is the interoperators. The first one is for the data transmission. China Unicom has a lot of enterprise customers such as government, bank, hospital, factory, and so on and so forth. For those enterprise customers with high security requirements, they have to transmit a large amount of valuable privacy and sensitive data through a trusted route passed to the data center. So with NASR, we can provide trusted connection service for enterprise customers with high security requirements. Through the trusted and verifiable router paths, we can achieve secure transmission and customers can verify the trusted paths. Next slide, please. The second use case for the inter-operator, we think that is based on the CAS scenario. We think that the based on the computing aware traffic steering working group background, we also have provided some distributed computing service to the customers, which can achieve better service response time and optimize the energy consumption. For enterprise customers who have large amounts of data to train and have high security requirements such as the autonomous driving, AI large model training, so on and so forth. We can provide a trusted connection service for these customers with NASR to transmit privacy training data to computing center and return the training result. So these customers could choose the service with designed security attributes and achieve dependable forwarding on top of only devices that satisfy certain trust requirements, which will avoid the risks of the traffic eavesdropping, sensitive data leakage, so on and so forth. So that's the three use cases I want to share from the operator's perspective of view. Thank you. Comments are welcome.
We have time for one or two questions. If there are no questions, we can move forward. Thank you, Yufu. Okay, so next up is Ramki. End-to-end use cases. Ramki, can you hear us? We can't hear you. You're muted. Oh, we cannot hear you, Ramki. Can you hear us?
You need to click on the microphone request button. That's what you're missing. So there's a button that has a microphone on it. You need to click it.
It's a bar in the bottom center of the Meet Echo screen.
Okay, I gave him.
Left-hand side of that bar.
Can you speak now? I gave him access. I can't unmute him. Can you unmute him? I can't unmute him. You show muted.
As far as I know, the chairs can't cause a remote attendee to start sending audio. The remote attendee has to do it for themselves.
Okay.
It would be kind of a security problem if you could turn on their mic remotely.
So in the interest of time, Diego, do you think you can cover this? Because otherwise we can switch, but then because that was his last presentation, and then we get
I can try to make a first a quick. In the
So
meantime,
Ramki,
if we can hear Ramki.
Yeah, Ramki, while you work on the your issues, we'll have Diego present. Sorry, I didn't mean to. Yeah.
I'll try. Well, basically, and this is the idea. This is something that I have been discussing with Ramki for the last month or couple of months is the idea that he's collaborating in Intel with mechanisms for increasing the trustworthiness on certain workloads, and he is working in it's something that is somehow related to what Mei-Ling was showing at the beginning. That is about how you can trust that the outcome of AI inference has been associated with proper data and has been properly transferred, and it has been executed by the AI that you were intended intending to make it. So the idea is to rely on mechanisms that include the attestation of the AI, the use of a secure environment or a secure network environment, and to increase this and to guarantee that the flow of data has been proper, has not been going outside of the intended border, etc. The idea is to add on top of all of this, in addition, the verification of the path. That the path has these certain characteristics that I was trying to exemplify during my talk. This is in the case of the inference, and connected as usual. And Ricky is very much fond of this kind of DLTs or whatever for making. Then you can make further auditing of the whole process by an independent party. Can you move on? If you look at the diagram is very, very, very similar. The only thing that changes is in the one case you are connecting to one single cloud provider or one single host. For this, in these cases, you are going through different ones, and you are relying on the same elements, and you are trying to use an additional evidence. Let me insist on this. We are not talking about, this is not a case only for the NASR mechanisms of the path validation mechanisms. It's using NASR as an additional evidence that everything went as it was intended by the customer, whether we are talking about a single cloud environment, or we're talking about a multi-cloud or edge cloud or whatever environment. Can you move on? Well, basically, this is about the proof of residency that, as you know, is something that is probably is one of the use cases that originally, or at least in our case, originally moved us to explore these ideas that the data is not leaving a particular geographically domain. And well, Ranky is here. We were discussing about those regulations that could imply serious implications for data residency. And well, there is the GDPR in the EU, some German regulations, and even in here, what no, down in the US, HIPAA. Can you move on? And well, that's let me say, what we see, and when discussing this with Ranky, talking about NASR and the technologies for path validation, is not only is using NASR as an additional evidence to verify that everything was behaving as expected and according to regulations. So the idea is that to be sure that I would not say before Volker stands up, it's not about the routing system, it's about the forwarding rules in the path. But this is something that we had to qualify carefully if we start to prepare a charter proposal, and making it in combination with other elements that can be used, and routing everything. I mean, I would say everything, because this heavily depends, even all the NASR technologies, and in particular TPR, in that you have a trusted execution environments that would allow you to provide the evidences and make the evaluations that are required. I'm sorry, I'm not about the inner details of the different check-ins and the technologies that Ranky has in mind. I'm not that much familiar. We have been discussing about that. I hope I have made a summary that is more or less accurate. And let me say, it's about adding on top. It's adding or below, maybe, because this is on the foundation layer of cases that are related with, Rankin says it very much on this, on non-deterministic output in the usage of cloud-enabled services. And I hope, Rankin, are you back? No.
No, thank you, Diego. I hope you're able to.
Come on, this is not serious. That's what you make me.
That's okay. No, thank you so much for Diego for presenting. I think I just want to also point out when you look at end-to-end, availability is a very, very critical piece. I just want you all to just recall the CrowdStrike incidents. Basically, people just waiting in airports for days together, right? So again, it's an important area which NASR can cover through trustworthy routing. With that, I would like to close and open to questions.
We've got a couple minutes if anybody has questions. Mike?
Yeah, Mike Perrock here. So as someone who actually deals with AI model like inference on regulatory data and evidence type data, I totally understand like layering this on. In practice, though, with both our enterprise and our government customers, I'm not sure that they would like want the added cost and complexity and then potential breakdowns network wise that could arise versus just like, hey, do we trust the encryption or not? But I could totally see that. I mean, what are your thoughts around the resiliency questions and things like that? What kind of cases do you see would add, merit the additional overhead here to add that extra layer? It's not that it's not potentially a valid layer. It's just I want to understand more there.
So good question. So I think two aspects. One is I would like to highlight on the importance of availability, right? If you don't have a trustworthy routing system, especially which work across multiple vendors and clouds, then you have a fundamental problem, right? Basically, you can be a monoculture, and then just like the recent CrowdStrike incident, basically your service is functioning right, but just not available from networking perspective, right? And second, also very important to remember, even though the data is encrypted using layer 4 information such as IP addresses and ports, you can actually infer a lot about what's going on, right? And I want to remind you of the AT&T incident of call records, where not the actual call details, but just the phone number exposure was a pretty disastrous situation. I think these are things where I think NASR would play a key role in kind of ensuring the availability and also the trustworthiness of even layer 4 information.
Hi, Ramki. Roman Danilou, I'm speaking as an individual. Could you expand a little bit more about the relationship of NASR and the CrowdStrike incident that I think we're talking about? What is the link between those two?
So
did I mishear?
I meant overall, in terms of availability is a very critical piece. So the system is functioning correctly, but let's say the routers were down, right? For whatever be the reason, right? And then you lose availability to the service. So the service is basically delivering the confidentiality and safety. Then that is also a big problem. That's what I meant from availability perspective.
Maybe I'll try it again. I guess I'm misunderstanding because my understanding from the little bit that I'm following along, I mean, we had a software update applied, and that was impacting endpoints. I'm missing the routing element of it.
No. All I meant was a similar pattern can happen with routers. That's why I meant with trustworthiness, right? I'm trying to draw a similar pattern. I'm not saying the exact pattern. Just like that, secure updates to routers and trustworthy routing, is essential for availability, network availability, just like endpoint, service availability. Correct.
Roman, we have been discussing about this, and my point when talking with Ranki about this was more about guaranteeing the auditability of everything. So detecting where things happen, and so the track is not lost. More than.
Go ahead, Sue.
I would ask that the preparers for the slides be a little bit more detailed. SAFnet uses BGP. Several of these things use BGP. And there's a lot of work done to validate the AS, the ASPA, and I don't see a lot of that, so it's difficult for me to figure out what you're really saying, I suspect. And why is it different than all the stuff that's done by the operators? I mean, they care passionately about whether the routing system is working and secure. And I do too, but I can't tell the details. So I hope the chairs of the BOF and the presenters will go a next level detail, because there's a lot of working. And Diego, you know I'm all about rats and the stuff and the security, but I hope the next presentation will be a little clearer about exactly what you're going to do, exactly where the
Focus.
the holes are, so what we can try to do a good job of comparing and contrasting this against what we have. Thank you.
That is great feedback, Sue. Thank you for that. The chairs will take that under advisement. This actually concludes the use cases presentations. And we're going to have Peter actually consolidate the summary statement of those and then get to the problem statement. So this is where we need that feedback.
Thank you, Nancy. So having said with all these use cases, right now we're trying to consolidate and categorize them. Next slide, please. So we kind of categorize them as 3 categories. So the number one is the leakage prevention of data during the wide area transmission. There could be more specific scenarios, for example, like when uploading data from campus to data centers, or when campus is communicating with other campuses, or you kind of training remotely from data centers to training centers. And also you have other data residency considerations. We all categorize them as data leakage prevention. How to define leakage, we'll talk about later. And then the second is that we want to provide the the option for the operators to orchestrate connectivity or path that meets the client's requirements of the trustworthiness or security properties, and such that the operator can offer some more high security connectivity services that has more, like a leakage prevention guarantee or data residency guarantee or security level assurance guarantees. So the properties that is not limited to the security properties, we could also include some capabilities that are enabled, like some reliability or resilience guarantees that are they're presented as capabilities that are enabled. And the third one is the routing auditing. So we want to prove traffic that actually went through specific elements in preferably orders, and also they went through elements, trusted routers that has specific properties. So the number 3 will be complementing the 1 and 2. Next slide, please. Next slide. So coming to the problem statement, one frequent question is that why a VPN or TLS between endpoints is not sufficient. So to answer that straightforwardly is that VPN does not perceive the underlying trustworthiness of the bearing network element. So the traffic could be accessed and processed by insecure devices, and this would permit further attacks. So like people will ask, like, so what, right? So the traffic is encrypted, but the encrypted traffic could also be exploited for various of attacks. So number 1 would be the crypto exploit. Now we have the post-quantum eras coming. We have store now, decrypt later attacks. We have crypto that was secure at the time, but now it's not secure anymore. We have MD5, we have blast radius. That's example just coming up. And then we have poor crypto engineering or poor crypto implementation, which is not uncommon. The fourth one is that the crypto protocols are only secure, until a new vulnerability is discovered. So maybe some new protocols are still in experiment stage. There's a possibility that future, vulnerabilities could be discovered. So the number 2 is that I think the more accurate description is a privileged middle box. So when a privileged middle box is in between of two VPN tunnels, like in a star topology, you kind of take the traffic from the first VPN tunnel, and then you decrypt it and you encrypt again and send it to the next tunnel. So this will be a plain text exposure in the privileged middle box in the middle. And then there could be also traffic analysis. We want to make sure, like, we want to emphasize that a successful attack is not decrypting all information from the encrypted message. Is you have, by cryptography definition, we can have more than negligible information from than he should perceive. So this could be like some pattern recognition from traffic analysis. Like we're starting to know like this endpoint is starting its operation, and maybe then we can carry on for some more cyber attacks. So, and the last one is that there will be no routing audit statement. And next slide, please. So the problem statement is that we want to achieve dependable hop-by-hop forwarding such that no deviation from a trusted path is conducted, and there's no like secret copying of encrypted data by those insecure or untrusted devices. So such that we can minimize the data leakage and exposure. So why, like we said, the data could be encrypted, but still, if accessed by unsecured devices, could be copied or cryptanalyzed. So how do we decide if the device is trusted? Because now we have rats, we believe something fundamentally has changed. So I think we think this is a right time to propose, like, how do we define a device as trusted? Like for now, we can say, like a device is integrity checked from bottom to up, from hardware to operating systems, all the way up to the configurations that performs the forwarding behaviors or forwarding decisions dependably. And we think that's the definition for trusted devices, and we want to connect them. So right now, because we have rats, before we have rats, we have no secured assumptions of the routers. We have no control of them. We believe they're doing the best they can, hop by hop. But right now, we have remote attestation. Maybe some devices are remotely tested, and they have this integrity guarantee, and some of them does not. So can we cherry pick them and connect them and provide a more secure connectivity service? Next slide, please. So the long-standing problem is that if we want to achieve routing security, or if we want to achieve dependable hop-by-hop forwarding, there's usually a two-step process. So the number one is that we want to make sure the routing information is correctly propagated, which is good. And this is what BGPsec and the other works in SetOps are doing right now. This is great. But usually the second part we have no control over. So like we want to make sure the router has obtained the correct routing information and is also making correct forwarding decisions. Like before we have rats or we have other integrity measurement procedures, there's no guarantee for a router that possesses this correct routing information, and there's no guarantee it will do as instructed. If there's also could be deviations or secret copying, there's no control over it. And right now, we kind of think some fundamental assumptions has changed. Next slide, please. Because before we have rats, the trustworthiness of a device is usually decided on which domain it is deployed. So if it's deployed in the internet, we assume there's no trustworthiness, is not trusted, is doing the best it can, and the correctly propagated routing information does not really guarantee correct forwarding. If it deviates, it deviates. Okay, we have maybe methods of detecting it, but there's no way of controlling the behaviors. And if it's deployed in limited domains, we assume it's completely trusted. Is it really unconditionally trusted? Maybe not, right? Maybe some devices in private domains, they are also, out of update, they're still untrusted. So this very binary view of trustworthiness is the problem, right? The real case, maybe that's not very binary. Right now, because we have rats, we have a more granular perspective of looking at the security properties or trustworthiness properties. Right now, maybe some devices in internet, they are trusted. We just don't know, right, for now. Maybe some devices in limited domains are not trusted. But now, when we have rats, we can have a more granular and a more deeper perspective, and then we can divide these devices and we can only cherry pick all these trusted devices or remote attested devices or devices with integrity guarantees, and we connect them. And we provide a more secure connectivity service. Next slide, please. Right. So one more step is that how do we define a device is trusted? So right now we can say like a device, if it's integrity checked all the way from bottom to up with the hardware, root of trust, operating systems, all the way up to the configuration, it is tamper-proof, that's fine, that's great, that's trusted. But we want to expand it more a little bit because trust is very subjective, and we are not here to define any subjective trust. We want to only provide objective properties, security properties, resilience properties, trustworthiness properties. We want to provide those options for the clients to choose from. And whatever satisfies the client's requirements, we can say that's trusted by this client. This client is happy. So right now we can, the purpose of our initiative, one of it is we want to provide all these options, maybe like, for example, the BGPSec is enabled, the young provenance methods are enabled, maybe flap dampening capabilities enabled. These are the requirements from the clients, and we pick the qualifying devices and connect them to make sure like the overall service meets the requirements of the client. Next slide, please. So the overall goal, before we go to the proposed architecture, the goal of NASR here is a three-step process. The first one is that we allow clients to choose desired security or trust properties of his received network service. We want to provide those kind of options for the clients to choose from. And number two is that by cherry picking all these qualifying devices and connect them, we should achieve dependable forwarding, hop-by-hop forwarding, by routing only on top of qualifying trusted devices that satisfy the client's trust requirements. And number three is that we want to prove auditable evidence that certain packets or important flows have traversed this required path or this connectivity that has certain trust or security properties. Maybe we want to know the order, maybe we want to know like the aggregated security properties. We just want to provide auditable evidence for regulation purposes or like audit purposes. Thank you. I think I see there's questions in the queue.
Yeah, you have a queue. Go ahead, Monty.
I'm Monty Wiseman from Beyond Identity. This is just making sure we're all connecting the dots with an IETF. This feels a lot like there's intersections with Whimsy, which is kind of a new thing coming, attended a BOF last night, and not entirely an intersection, but I think you should coordinate with the Whimsy team so we don't get duplication of effort. Probably 60 or 70%, just my guess, of what you're talking about here is also being discussed in the Whimsy group. I think they're great, both initiatives. I just want to make sure we don't duplicate efforts.
Thanks. Thank you.
Roy Williams, Microsoft. Hi, Peter. I read through the use case document that you have posted or linked to the presentation. There's some verbiage in there that's a little confusing. Like client, in this case, to me sounds like a user, where it's really the organization that wants to establish this. So if you could clarify that, that would be great. In 5.3 of the section, you talk about prevent, and you've gone into a couple of cases in these presentations of prevent or control leakage of data. I'm fine with auditability, but as soon as you trip into that section, it raises a whole bunch of questions. And in your use case, 7.2 section, that says it's out of scope to cover prevention or control. So there's some mixed signals in your use cases that it could help if you clarify them.
Right. So we want to start from simple cases like before. Like the simple case that we have is that we provide those services to businesses, to organizations, like for providing those secure connectivity. Or maybe in the future we can have more service to the ordinary customers. Like for example, maybe they want their emails to traverse a secure route. Maybe that's something for the future. But if we want to start simple and make it tractable, we want to start from just a case for business connectivity service.
Kathleen Moriarty, clarifying question. So in the chat, there's been a bunch of discussion about brittleness, which makes perfect sense. what I'm wondering, just from past working groups in the routing area, sometimes they're limited to like an administrative domain. Is this meant to be limited to an administrative domain? I don't think it is, but that might be a way to constrain it. Or is it meant for the big internet or hybrid cloud use cases?
Right. It's not limited to a private or limited domain. It's because like some cases, a long connection connectivity service is wide, spread geographically. Usually that needs operators to collaborate and across many different domains. I think the Fu Yu from China Unicom has addressed that. So the thing is we want to, define how do we exchange information, how do we define the formats.
Right. So the brittleness problem arises more prominently when you're crossing multiple domains.
You talk about so in general sense, I more or less agree on the broad goal of this one, but I have some gap. I feel some gap between the scopes of this whole work. So you mentioned in the routing is you mentioned first about the BGP. It's very global, worldwide setting, and we also have, as I said, if we focus on the multi-cloud or something like that, it has their own software-defined network or something like that. But as a solution, you mentioned about the RATs or something like that. It's very hardware dedicated, in some sense, local and very well managed closed network. So. If scope differs, the targeted technology really differs on that. So what is assumption on the variety of network implementation or variety of scopes about the problem?
Sorry, what is the assumption of?
Assumption on the use the hardware architecture or network architecture or scope or something like that. So in my feeling, that is very applicable for very local managed devices very well. And BGP is applicable for very broad networks problem. So I feel some gap between that. How do you feel about that?
Okay, so the RAS working group, tries to give like a attestation result, like by verifying which you don't have to look into the details, but you can still, check for the integrity. I think this is the case where we kind of extend to the multi-domain or multi-operator case. Like operator A does not have to look into the details in the operator B, but still there's like a integrity proof or attestation result that can be verified to make sure that I don't need to look into your network, but you're providing this service correctly.
Okay, I understand how you feel about that. Thank you.
Okay, I think we need to move on.
Yeah, we closed the queue
okay.
a couple of minutes ago.
Oh,
yeah.
okay. Oh, good.
You can ask in the open mic session if you want.
I feel like that last talk ended kind of abruptly. Hi, I'm Michael Richardson, and so I have some diagrams that you're free to throw tomatoes at, but I would ask you to wait till the end of the diagrams because I like to present the bad diagrams first, get you all enraged, and then we'll find it better, right? Next slide, please. So this is a diagram that the inner part has gone around a bunch. And this is kind of one of the concepts that people had, that there's, a customer that has some needs to traffic between different locations, and they're going to talk in some way to the network operator, get some stuff, and then they're going to send some data in there, a tester on the left, using some kind of proof of transit mechanism. So, for instance, you can go read Diego and Luigi's document. They have a document in that is one example of proof of transit. And okay, this is interesting, but you see there's some gaps and some arrows that are missing and stuff like this. Next diagram, please. So then you can imagine that in fact there's traffic between two different customers that traveled over a particular operator. And So there's many cases, the use cases, people said, like, oh, well, one's an AI, one's an enterprise that has data that they want trained on and things like that. In which case, you have this other gap between the green and the reddish side where you have to get, in order to be sure that the path was taken, you have to get information back from customer B. So why does this matter? Well, because customer A has a relationship with the network operator, but what's customer B's relationship with that network operator? And we need to make sure that we need to take that into consideration. Next diagram. So this is a little more complicated, but I think it's a little more realistic. So we have customer A, we have customer B, we have two network operators, and these moony, shapy OR gate things that I just picked, whatever. That's the kind of API that customer A has to have into their operator, and then we have to have some relationship between the operators. And then customer B is connected to operator B and or operator 2, and has to feed back some information. And finally, the important other part is that the network operators are collecting evidence on their devices, and they may need to, for instance, go back to the vendors of those platforms in order to who have the actual remote attestation reference values there. So if you're familiar with the various RATS architectural or mechanisms, we have passport checks and background checks, and I'm pretty sure that we're probably going to have to, that the background check is the right model, because effectively we don't really want your routing platforms to reach out to your verifiers elsewhere. And maybe they can't even do that until they actually have network connectivity. So at the bottom, you can see, for instance, the possibility that protocol between the orchestrator and the routing platforms is I2RS. Are there any I2RS authors in the room? Yeah, okay, yeah, all right, good. Because I hope you'll throw tomatoes at the right place for that. And so in the RATS working group, we have, for instance, a way to get TPM evidence out of a device over Yang, and so that's actually a possibility. Like, there's a piece there that probably all fits together if we do the right things. I'm sure there's some details that matter. And then there's a bunch of TBDs that, this is where we're trying to figure it out. Next diagram. Just some variations, you could run the verifier inside the network operator if you have the appropriate reference integrity measurements and things like that. And there's other ways of figuring things out. Next slide, please. So what's the gaps here, right? So there's inside and between the operators. There's pieces of protocol that we can run around the IETF and we can pull some things out. I2RS I mentioned, Chara, TPM Chara. There's some other options about there, and I think that if you have a protocol that you think fits, then or could be extended, then I think mailing list is a place to discuss it, because ultimately when we get to a point where we say we're going to be chartering, then we're going to be saying, and we'll coordinate with the blah 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 working group if it's still alive. I think I2RS is not alive. Is that right, Sue? I2RS I think concluded is what I'm saying, but the protocol's out there, right? Then we have this orchestrator to orchestrator connection between the operators. And if you're going to do proof of transit across it, as I understand it, you may or may not decide that you want to do proof of transit across both operators, and the keys that are required to make that happen may need to pass between them. Alternatively, each operator does its own proof of transit and collects something up. Alternatively, we have two layers of proof of transit. Well, the first layer is within the operator, and the second layer is essentially treating each operator as a single node, okay? And that has a different impact because that's more costly, right, for things to do. But that might be the right answer, right, there. That's the kind of things that we need to figure out architecturally, not necessarily for chartering reasons, but we need to know if the question, is that a question we are going to have to address or not? And then we need to probably, we don't need to standardize the exact mechanism by which each operator does verification of the routing platforms. We can say this is the right RATS mechanism, the right thing, and there's clearly savings to implementers of orchestrators or other things that are going to do that, of having fewer protocols, but they could, in theory, have more things. Okay, so then between the operators and the end customers, so we need a protocol there, right? And you realize it's crossing a trust domain, and they have to have a business relationship. This is not for random things, here and there. I think there was some chat in the thing about worry about IAB kind of, web server saying no. But the reality is that, well, this is not out there in the open wide internet between random strangers, okay? It's also not a limited domain. So it's somewhere in between where we have a set of business relationships. And so we are going to have to facilitate that. But we're also, it's not like a random website you go to and say, I would like some bandwidth to Honolulu and please give it to me. No, you're going to have some relationship that you're going to make with. Next slide, please. I think that's the last one. Yeah. Mic time, please.
Just clarifying question. So what is the orchestrator in this presentation? Maybe because the term is used in various areas, in various different meanings. So we need to share the concept of the orchestrator in this slide.
Why do you have to ask hard questions like that? What, you want us to have a definition? So let's just say it's a thing that arranges stuff. And in an SDN space, people know what that means, and that device has the relationship there. If you were not doing SDN, if you were doing, and there's a lot of discussion in some of the documents about SRv6, for instance, but let's say you're just doing OSPF across your network, right? Then it's probably a device that has to go and collect all the evidence, the attestation evidence from your things, okay? And it has to provide that API to the left and the API to the right. And if you have a better term that's more generic, then I would love to put it in my slide.
Okay, thank you. So my understanding is that orchestrator is orchestrating the existing network, and we want to verify that, not orchestrator of our architecture or something like orchestrator of the underlying network.
I think it goes and orchestrates non-attested paths too, but so to me, leveraging that system is there. If someone says, oh, no, but I don't want to mix my secure and unsecured or my verified and unverified routing, then maybe you need two platforms, or I don't know. I think that we can define the APIs to the left and to the right. And I think that RATS can define or can document the APIs up and down, okay? And then we can not worry about exactly what is inside.
Yeah, so orchestrator is the one we want to ask for something.
Did you go back 2 slides? Actually, just put that. Maybe one more.
Okay,
because
so
that's a dirty slide.
and
Go one more back.
Okay.
Yeah. Okay.
Thank you very much.
Yeah, but it's kind of messy, kind of bad.
Yeah, I agree with your definition. Thank you.
Sue?
So just to put a little history on it, I2S is not a protocol. It was a working group that defined models and additions to the Yang functionality, which took some time to get into it. In addition, at the same time, we were trying to do what you had, Michael, which is I2NSF. Now, we didn't get a lot of feedback when I worked with that. So been there, done that, got the t-shirt, want to know why we're going to work this time.
So you're right. So I2RS is really a set of Yang modules. And so really, if I were to label these arrows better, then I would really be saying this is RESTconf. Oh, no, I would not. This is not that way. Okay, well, if you're doing TPM Chara, then you're probably doing RESTconf. And so the belief I have is that whatever your management protocol, your north side from your devices to your SDN, whatever that protocol is, that's the one we want to extend with evidence. So if I'm mislabeling it, that's because I'm not a routing person. And I would love to know what protocol I should put on that label as, yeah, there's mixed, yes, okay. Roman.
Hi, Roman Danielu, speaking as an individual. I'll have to confess, I'm having a lot of trouble following along across all the different network architecture diagrams across all, all of kind of the use cases. So in the beginning, I thought I heard things around service function chaining, and I was like, great, that's limited domain. We have kind of a lot of guidance. And then I heard you kind of talk about, well, it's not limited domain, it's kind of something else. And I know we had a lot of use cases, so I don't want to conflate. So like, help me understand, who are the parties in this path?
So I'll give you an
control?
example from the stuff that I understand from other please. So the Scion people in the room, please jump up and tell me what I'm completely insane. My understanding, for instance, is that in Switzerland, there's a requirement that banks exchange information when they do their stuff, that traffic remain in Switzerland. So specifically, no fiber between Geneva across Lake Geneva through France to the other part of Switzerland that's to the south of that. If you know the geography, it's got this like, you can't do that. You got to go around the lake, all right, the other way. Sure. And so that's an example of you have to stay in the country, which means that you have to. So there were some diagrams that Peter's had a better one where he had the green routers in the middle and the other ones there, okay? And so in that case, customer A is Credit Suisse, and customer B is, I don't know, another Swiss bank. So, pardon me, someone said a name. Anyway, some other bank, Bank of Zurich, right? And so they have a requirement, but they don't, of course, want to buy all their internet from the same operator. They want to have a market of internet connectivity. They're going to buy it from the right guy, from the friendly guy. But the requirement is that these guys have to provide auditable evidence that it stayed within Switzerland. And so that's why we need to have different APIs across this. The evidence has to flow back and forth, and the banks ultimately have to put it in their audit log so that later on when they get audited, they can come up with something useful. Okay, so it's not limited domain, it's just Amazon. Like that's what we normally think about limited domain within the enterprise, but it's also not, internet everywhere. It's somewhere in between.
I appreciate kind of that clarity. I don't know if I got that assessment and that distinction from some of the way the other use cases clarified internet, not internet domain, how much provider intermix with kind of customers. Is it endpoints? Is it just kind of management devices? I'm struggling a little bit.
Yeah, I would make up a silly term like unlimited domain. I don't know, right? It's not open, but it's, that would be a terrible word, but
I mean, I think you can absolutely do that, but then the internet threat model applies, and
yes,
there's a conversation.
Yes, and I think that this is an appropriate thing to say is that actually these are people that want to route traffic over pieces of the internet where the internet threat model applies, and they want some assurance that bent fiber didn't happen, right? Sorry, I don't know.
Yes, it's Gunther speaking as an individual here. So actually, I have a clarifying question. If you can go further one slide.
Back one more.
So I should just clarify, given that
these are, yeah.
I'm just going to say, I'm looking at the agenda time with Luigi, so we're just into the open mic discussion. So.
And I also want to say these are straw man slides, which you should hate, and which is going to encourage you to write a better slide.
Yeah.
Well,
right.
I think as the chairs, you're providing diagrams, and that's what we're trying to assess, right? Of, are these well, it's not that they're the right diagrams because you're saying they're ugly, but it's to help this audience understand the problem statement that the constituents are presenting. And if there's confusion, so as Roman asked the questions, there are things that we can come back and clarify.
Right. So what was your point? Yeah, sorry.
Yeah, so wrong picture. I need something with routers on top,
Oh, there's no routers in this picture.
No, it's like further on. Something with next.
Oh, yeah.
Yeah,
so,
here. So the connection between that green router and the blue router, is that actually a link?
In operator 1, that green router to blue router inside the gray box?
Yeah. So there's an arrow there,
Yeah.
Is that a link?
That's a forwarding link, yeah.
A forwarding link.
Yeah.
So can this be a tunnel?
Of course.
So one of the objectives of a tunnel is that it sends traffic over it, but it hides the underlay topology.
Yes. People don't like, that's exactly, it would be bad if it was a tunnel that we couldn't attest to, right?
So
And so people would prefer not to put a tunnel in there. They would prefer to put, like, you know, an SR6 forwarding thing, which would actually have evidence from every hop, but would still be a circuit and not a tunnel.
So the way I look into it, you have like two orthogonal requirements here. One is you use a tunnel to hide the underlay, and then with this technology, you want to actually show the underlay.
Right. Yeah.
Interesting.
Yeah. I don't. So what I perceive is it means is that you will not be tunneling by between two things within the AS by encapsulating. You will be putting a mark like SR6, for instance, such that you now could see each hop that way, along the way. Maybe I'm saying it in a silly way because I'm really not a routing guy, but anyone else?
Yeah.
Open mic? My open mic, I think you're saying at this point.
It is
You want to
open mic.
just go
Well,
to
it-
remove
yeah,
the
I mean,
diagram,
this
or
is-
unless you want to, I'll sit
No,
down.
I mean, I think this diagram captures the high level problem, whether it's the right diagram or not. So,
I just want to know if you want me to stay at the mic or if
well,
it's open mic time.
it's open mic time, so you can stay here, or we've got a long queue. So, was that Gunter? No, Nicola. Gunter's just fuzzy.
This is Nicola from Zion.
I'm hiding.
You're hiding.
So echoing on the Swiss bank use case, I mean, that's basically why they are already one of our early adopters with the Zion network, specifically in banking.
Not using tunnels.
Well, yeah, right now this is going over tunnels. So I think there is it would be probably a topic later today in Panergy. So going back to this, so I think Zion already partially addresses that in the interdomain case. When it comes to intradomain, the approach of Zion is that we assume that we trust the autonomous system. So I think here maybe there might be a gap that where the two things could be, integrated. But there is a bit of difference. And of course, Zion, in the way that this is deployed today, it doesn't do proof of transit as well, which I think is something we discussed a bit on the chat. So I just wanted to comment on that.
Thanks. Mike.
Yeah, Mike Perrock here. I definitely get the use case. There are things that make me deeply nervous about this, right? And I'm not naive enough to think that bad people aren't going to do bad things, but especially some of the diagrams and when we talk about like unlimited or infinite domain or internet scale or country to country type stuff, right? On some of these slides, it strikes me as the kind of thing that a small L Bonian dictator would be like, this is great. You just made it much easier for me to roll this stuff out. And then the vendor that sold them all the hardware just yanks the chain when they didn't pay their bills. So like, I see some concerns that could hit populations in disaster recovery scenarios or economic warfare type situations. That all being said, I think that this work is going to proceed anyways. So it would be much better for this work to happen in the open with good guidance and us thinking clearly about like, well, it looks really brittle and fragile. Great. Now let's go try to tackle some of those brittle and fragile problems. Or maybe there's some good guidance around how we can prevent abuse of this in certain areas and certain security properties we may want to ensure exist when these types of systems are deployed. So that's kind of where my brain is at now. I'm definitely open for other feedback and thoughts, but it feels like something that's going to happen regardless. Probably better for it to just happen with good feedback in from lots of parties.
Ike, I think you're volunteering to help provide that feedback.
One addendum, me and my big mouth.
What?
Wes Hardiker, USC ISI. Trying really hard to wrap my head around this. So the good news is that I think I understand the use case. I think I understand the need. So, that makes sense. I get why this is needed. I think the bank example in Switzerland was a great example. So I'm going to drill into it a little bit because I fail to see how this works in anything beyond a limited domain, including probably an unlimited domain, right? Or whatever you are wanting to call it, right? So consider like the banks in the country. Bank 1 and Bank 2, are communicating through multiple hops through whatever region. And the problem is when there's 2 network operators, this architecture kind of works. When you're getting to 10 banks, 10 network operators, and stuff in between, then I fail to see how this scales when you're also trying to tie this into the internet architecture, which then has other clients to these network operators that don't care of whether they get a trusted path. So then without getting into how do you do this without multi-hop source-based routing techniques with packet marking to say, well, this bank needs to send money to this bank and it can only go over a trusted path with no overlays because we've sort of dropped that as a solution space, right? And yet this other person, might be coming from a customer client, through a network operator that just wants to go to the web page of the bank. And so I fail to see how you can do this. In an air-gapped, network, this works great, but in an air-gapped network, you also don't need it. So fill me in.
So I think that one of the things, Wes, you should look at, and it's difficult in some ways to present things, multiple things, but you should understand the reason I put routing symbols at the bottom of this and the previous things just said attesters is because I really wanted to show the fact that we're actually in the forwarding plane down there, and the customer B has this path evidence that it actually needs to evaluate. So there's a header that's actually been added that has this proof of transit that is in the forwarding path. Some people argue it's too costly, blah, 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 but effectively other people have said, yeah, but the customers are willing to pay for it and the vendors want to supply them, right? Ruder doesn't think the customer is willing to pay for it, but the point is that if they have paid for it, then they do have something on the packet that arrives that they can evaluate. So they can either put that packet into their, wire transfer system if it's legitimate, or if it's coming from a source address they don't care if they trust, then it's going to get to their web server appropriately, right? So I don't think that it's a problem that the traffic arrives potentially, over a single link, not air-gapped, because it is marked, and it's marked in a cryptographical way that they can actually assess. That makes sense? You look very skeptical to me. Okay.
Just the 2 comments, but I guess they are related. One is what Gunther was mentioning about tunnels. The idea is not to expose the tunnel or the details of the tunnel. The idea would be that if you're using a tunnel, I can provide you some kind of evidence that the tunnel doesn't leave Switzerland or Elbonia, and this is connected as well with what Michael was saying, the kind of protection that you can put in not exposing all the details, whether of topology or personal, etc. It's something that is a point that at least is in my mind. I'm not saying that is and we can reflect it in the chapter, how we abstract while maintaining the trust relationship. For Switzerland and Elbonia, anywhere.
Yeah, thanks a lot for all of this. This is very interesting and to me, and I'd love to see this going forward. Unfortunately, of course, because I think we already did a pretty good starting point for, what I would think a secure network service would be, and that's pretty much what we did in Anima, right? We do have networks that we're building with secure routing properties per hop, link encryption, enrollment automatically for all the participant devices through a crypto chain. So if for the enrollment we simply add requirements for attestation, we'll end up with, you know, a secure forwarding routing service with a lot of security properties that also has other properties like, oh, devices can only be in one country or from one vendor or with whatever other security properties. And from there on out, I think there are a lot of variations on how one could build, you know, similar principle-based NASR instances. The 2 points I think that would be beyond that self-promotion, sorry for that, I think helpful would be, for once, it would be lovely for people to come up with the most simple use case scenario that they think they would want to get into NASR and then have those beaten up, right? I think the work that I've seen so far had too much generality, so it's really very hard to review and get to the details where people make the decision this makes sense or not. So as simple use case as possible. When people think about them, please bring them up. And the second one, and then I'm finished, is I would just love to see you know, NASR options that do not depend only on proof of transit, but that can also work without proof of transit. And I think that's perfectly feasible.
Okay, so I have 2 questions for you, Torlis. Don't go away, since this is open mic. So you mentioned Anima addressing, I'll say the routability maybe?
No, it's RFC 8994. Sorry, way too long, way too much in it, but it's pretty much, you know, you've got your certificates on the list of trusted devices that you have designated to build the service from. And they're establishing from those certificates per hop encrypted links and run all the routing within that domain. I'm not saying this would be a typical NASR deployment, but I was saying this is one, you know, possible instance of such.
As the only implementer of 8994 to date, it would be appropriate for there. But I don't see it left, right.
No, why not?
Yeah.
Why is it not appropriate left, right to have per hop link encryption? That's the best way to.
But that's not an ACP. That's per hop link encryption.
No, but the ACP itself does have per hop link encryption.
Yes.
Yes.
Yeah.
And that's all I was talking about.
I just don't see it. I don't see it's a helpful step for us here.
No, wait a second. So I do very much think that per hop link encryption provides you with the most secure network services when you really want to ensure that you do also not have, you know, at least a lot of observation of the non-desired transit, right? So, I mean.
Yeah, so what I'm hearing, I think moving forward for the next steps is for us to clarify the dependencies and or the gaps, I should say, because the other gap I was going to say was with Anima, you do talk about the trust and provisioning of certs, but here they're talking about defining the profile with a set of claims to get to what.
Oh yeah, that definitely. ACP would be just one example possible profile you can build out of that, right? So the whole the core aspects to me are, you know, per hop link encryption is a great way to provide without proof of transit path properties that cannot be broken, and then of course the whole derivation from trust anchors and the appropriate enrollment with specific functional limitations, right? Because one of the other things that Anima does, which I think would be great for many NASR deployments, is that it nails down the real functionality you want to have and just not lists that some random features are being configured, which is a much weaker attestation as to what you ultimately get out of it.
Wait, go ahead.
Direct question for Turles, but Anima is definitely, or seems to be definitely limited domain.
Yeah, so when we originally implemented that for enterprise customers, the limited domain we're thinking about was a global bank with 150,000 routers. That's what we wanted to scale to. So yeah, nothing larger.
Okay, my second quick question second quick question to Torles. You said you wanted simpler use cases. So
yes,
are you wanting it to the level of what Michael just described vis-a-vis the Swiss regulatory?
So I think I understand the Scion use case, and I have a hard time of mapping that to NASR. But yeah, I mean, if we want to take the Scion use case and revisit that, we'll need to figure out which of the Scion aspects we could leave out just to nail it down to the NASR aspects.
Okay, thanks.
Rüdiger Volk. First, Richard, you did see me disagree. The thing is kind of you were talking about cost. Kind of when I'm looking at it, I'm seeing kind of cost and making things more brittle as the interesting challenges. For the cost, it looks to me like the cost will be very high, and probably it will not be a valid proposition to take your current as a service provider, as a network operator, your current general purpose backbone infrastructure and enable it everywhere for this, and kind of only a minuscule part of the customers will be willing to pay for it. A couple of decades ago, I had similar thing like, well, okay, we did know we could do quality of service. And the product management was saying, oh, we really want it. And well, okay, they didn't have the paying customers for actually replacing all of our hardware for double cost for actually doing it. So kind of the brittleness here is probably going to be even worse because much less resources will be available to users of this. The good side of...
I think that you made your point. The economics may not work out. And I think we have 3 more speakers in 1 minute. So
yeah. Kind of the good idea that I'm taking is Diego's remark that, yeah, well, you may not need, or some customer use cases may not need for every data packet to have the proofs, but making it make everything in the data flow auditable is something that, yes, kind of just as a general as a simple general operator, kind of, yes, that would be nice, though kind of I would not be looking that much about the very specific characteristics of each network element. I would be essentially interested into, well, okay, does the data really go from where I think it should be originated to where I think it should go? Yeah, we all have once in a while had experience where things did not go where they were supposed to go.
I'm going to have to ask you to accelerate because, yeah.
Yeah.
Go ahead.
Are
you done? Because we have 2 more and then we have our AD.
Yeah. Kind of the other thing that goes beyond just verifying the data plane operation is, kind of discuss what properties you want to have from your data path, and actually kind of what elements are used for it are, in my opinion, irrelevant if I can prove that the property of the actual path is there. And discussing what characteristics are relevant there and how to communicate the request of a customer,
Rudiger.
I want these properties to be.
Rudiger, sorry. So I understand you are volunteering to scope the problem, right? Yeah. Yeah. Thank you. We want your help.
You take over. I almost agree with him. He said almost everything about I want to talk about. Because I joined this group from the side meeting in Prague, and because we are, including me, we are technology people, so we are seeing what this protocol can do or something like so. Things getting from bottom up. But important point is, as he said, what the customer wants and how to access it in the data computer domain and how we can verify that. So I want to focus more on the top side of requirements analysis and how the requirements are encoded into data. And I also agree that path of proof of transit is important technology, but completely optional for this. Or if we can do this kind of thing without proof of transit, then we have much more customer.
Okay, we have a second volunteer to scope the problem.
Of course.
That's
I will
excellent.
Yeah.
Looking for a third one, Andrew.
Hi, thank you. Andrew Camping. I'll make two brief points. One is, building on some of the comments from other people, I really think some attention needs to be given to the implications for network management network management by network operators. You're running the physical networks that this stuff is running over. Because like some of the other protocols that we've developed, they seem to ignore the fact that network operators do want to run sort of high quality networks, and this potentially overrides that. So I've got some concerns there linked to brittleness. And then secondly, even though I'm an internet fragmentation skeptic, this does seem to facilitate internet fragmentation. So given that some people think that's important, they probably want to think about that as well. I guess that sort of links to the comments about bad people would do bad things anyway, but it doesn't necessarily mean to say you want to build the tools to make it easy for them. And I'll stop there.
Thank you for volunteering as a third person to scope. Deb?
Okay, so I'm Deb Cooley. I'm the security AD that's responsible for this buff. Might be strong. Yeah. So thank you very much for coming. Thank you very much for presenting and expressing your opinions. I think at this point we take it to the list and see where we go for here. To me, it's not clear necessarily where we go. I believe this is fairly complex. It's probably expensive to implement and brittle, right? So the question is still needs to be worked out whether it belongs here and how it looks if it belongs here. So thank you very much. Yeah, we'll talk about whether it's security or routing,
Okay.
Maybe art.
Okay. Okay.
Yeah,
they're all on the data tray.
Yeah.
So all the presentations are up on the meeting materials, by the way.
Hello.
And thank you to the note takers.
All right, I think we made a lot of progress with this, right?
No. Well, they had a discussion in the
Yeah.
And so from there,